go to the slides.
Wait, is it recording?
Yeah, it should be.
How do you know?
SQLAlchemy.
Oh, it's
It says
here.
right here.
Oh, okay. Cool.
Oh, that's lit.
Okay, wait, you wanna? Okay, wait, let's make.
Is this on?
Did you turn it on?
Do I have to? Okay. And it just wirelessly does this deal.
Yeah. All right, we're gonna get started.
Just say.
All right, yeah, so we're gonna get started. First, Shruti, who's on AppDev, she's gonna talk a little bit about Polo.
Yeah.
Right? Yeah.
So I just have a quick announcement. So yeah, hi, I'm Shruti. I'm with AppDev and I'm on the Polo app team. And just to provide some context, so Polo is an app that provides a free interactive platform between students and professors to ask questions and receive feedback via live polls. We're currently looking for students to participate in a user research group. So if anybody's interested, then please email ssa67@cornell.edu. That's my email ID, and we'll definitely be in touch with you. So we'd really appreciate it. Thank you.
Nice. Okay. Oh yeah, and sorry.
Logistics first.
What?
Go over like.
Okay, yeah. So Connor's gonna be doing the lecture today.
Howdy.
He's on the Backend team. Let's see. So we have some logistics related announcements. So the 4th project is out, like all the others. This is weekly, so it'll be due this Sunday. Project 3 was due yesterday, right at midnight. Let's see what else. If you would need an extension, again, like you should be requesting extensions like 24 hours in advance if you need one. What else?
That's it.
Oh, okay. Sorry. So this might seem pretty random, but someone on LinkedIn added AppDev as like their organization and then added everyone on AppDev, and I think it's someone in this class. So just like as a, I don't know, like a reminder, like this is not being taking the course is like separate from being a core, like a developer on the core team. I have no idea who the person is, but I think like the president of our organization like got in touch with the person. But yeah, this is just, I guess like if you have any questions related to that, you should post a note on Piazza if that was unclear. But yeah, I think that's it. So Connor will get started. Yeah.
Sup, I'm Connor. We're going to do some cool stuff today, talking about ORMs. We'll get into that later. So what can we do right now with what we've learned so far? So if I'm correct, you guys just did some stuff with Flask and SQLite. And so you're messing around with databases and tables and adding things to your tables versus just having your own custom objects. So we're going to take this one step further. And, that's the question. Yeah, so when we're integrating our code with a database, we want to use a specific connector. So, and we can choose our language of choosing. So for this course, we're going to be using Python, as you're well aware, and we use connectors we need it, as with any language, just to connect to our databases. So this gives us a low-level base SQL functionality. The SQL that you've been taught so far is pretty low-level. It just like select all from our table where these conditions are true. I'm not sure if your conditions, if any exist, but yeah, we're doing some very basic SQL so far. So what is wrong with SQL? So first off, I'm not sure about any of you, but when I was first learning SQL, I thought it was a bit trippy with how it was written. It took me there's a learning curve to finding out this is how to do all my queries correctly. And there are also actually some ways to expose SQL and abuse it. One of those methods is SQL injection, which we'll get into later. So the code isn't as readable with raw SQL, along with it's complex to write, but once you get past that learning curve, it's relatively simple to conceptualize. So along with that, you can increase your susceptibility to bugs within your code, which is not good. We don't want to leave endpoints exposed and have room for things getting abused. So, and then SQL injection must be handled manually. And so we'll talk about SQL injection then. So what do we consider the worst downside of any raw SQL? That would be SQL injection, aha. So SQL injection is basically the act of accessing a database like forcefully without correct authorization and from an external source using crafty user input. So it's basically someone out there is trying to access your database. They're not part of the organization. They're not a client using the app normally, and they're trying to gain data wrongfully from your database. So this user input, whatever they're putting in, would contain like some weird SQL queries that can allow the external source to gain access to otherwise restricted data and query on this data and delete or even corrupt the existing data, which can mess with your application and your current database, which is not good. So here's an example. So here's some random website with a Yeti on it. You're going to go in and log in, and maybe it's a social media platform like Reddit, like the thing we're making right now. So you'd go in, and the first thing you're prompted to do is give your email and password. So when you put in your email and password, that information is then sent to a database that authenticates that the email and password correctly align with an actual user in the database system so that it can give back the correct information to you. So at the top line, we can see select from users where email equals email and password equals this hashing algorithm on the password. So the supplied values, as you can see, are in gray, the XXX at the random email server dot whatever, and then the password this is where the SQL injection is taking place. You can see that you have the XXX apostrophe and then that other stuff, and that is that's the crafty user input that's trying to abuse the SQL and pull out some weird stuff. So in the next line, you can see how this gets inserted at the end of the MD5 is it kind of like cuts off with the parenthesis, it kind of like finishes that MD5, and then it has this extra or 1 equals 1 statement after it. And what that ends up doing is like 1 equals 1 is evaluated as true. So as you can see in the next line, the simplified version of this query is select everything from users where false because you provide a false email, and false being the incorrect password you gave, or true, where the true is then the 1 equals 1. So we evaluate the first false and false to give us another false in the next line. And so now we have select everything from users where false or true, which evaluates to true. So now we've just given access by saying select from users where true. So now whoever put in this SQL injection messed with the code in our internal system to falsely input that true statement and have it trickle down all the way where they can access everything that they want. So as you can see, like this is no bueno, this is bad in like every circumstance. We don't want anyone to be able to go into our databases and just pull everything they want from it. And so this is one of the biggest issues with SQL currently, and developers around the world have to deal with this all the time to fix it. And there are solutions to this now. SQL has been around long enough where we have some crafty solutions, one of which we'll get into later today. Any questions about how I broke down what's going on here and how you can use the injection to create a false true that trickles down all the way to evaluate as true in the end? We're all good?
Wait, and also MD5 is just like a hashing algorithm, so it takes some input and then outputs like a string so that in like the database you're actually not storing the plain text of the password, you're storing a hashed version of it. So like even if your database, so like when companies say, oh, like our databases have been hacked, they actually like don't have the physical password, they have a hashed version of it. So yeah.
This is a little comic strip, but you can read through it. So, hi, this is your son's school. We're having some trouble. Some computer trouble. Like, oh my God, did you break something? In a way. So, did you really name your son Robert, apostrophe, end parentheses, semicolon, drop table, students, semicolon, dash, dash, question mark? Oh, yes, little Bobby Tables, we call him. Well, we've lost this year's students' records. I hope you're happy. And I hope you've learned your lesson to sanitize your database inputs. So basically what happened here, the main SQL injection is at the Robert in that weird drop table students thing right there. So looking back at this slide, so this was basically inputted at the end. And so what this database at the school is doing is they're just taking that string and just putting it directly in the database. And when the database reads drop table students, it's like, oh, okay, I'll drop this students table for you. And then that's how they just lost everything. So as you can see, this mom just like totally played the school, but we don't want this to happen, which is why we like to make sure that SQL injection does not happen once again. Yeah, I found this one kind of funny. So how can we make our lives easier? How can we deal with this SQL injection and make sure that our databases are secure and safe? Solution is called object relational mapping, also long for ORM. So ORM is a technique for taking data between incompatible type systems using object-oriented languages. So if I have a database on like MongoDB, and I want to take some data from it, I'll query from Mongo and I'll put it into an object, a custom object, and I'll define it with a class and such. And what I can do with that object is then use an ORM to like send that to another database. So it allows databases, it's kind of like a unifying structure for keeping data like the same classification, like same structure. So you can move it between many databases, and it's very flexible in how you use it. So this, in essence, creates like a database of objects. So we can use it with any language of a backend of choice, and we can reason more about entries as an instance of an object versus simply a row in a database. So it kind of lets us think more about it from a computer science perspective and what we're being taught in our classes versus just thinking columns and rows as traditional databases have been. So there's people who like to make money off this, but there's also a lot of open source free stuff out there. We'll get into some of those like further in the class, and I'll show you an example today. But they're perfect for performing object relational mapping. And although like some programmers choose to create their own ORM tools, especially like companies who want to keep things internal, like maximize securities, they'll just develop their own ORM tools to use, and so they don't have to worry about any open source or paying another company to do it for them. So ORMs are like a very common thing to use in like the world of databases. So some examples, so like for Java, we have tools such as Spring and Hibernate. For Python, we'll be using SQLAlchemy later. And then for Node, you have that logo is Webpack, I believe. Yeah, it's Webpack. So just some examples. These are just like name tossing. It doesn't really matter, but yeah. So here now it's time for an example of object relational mapping. Warning, plug and bound. I work on the Eatery app, so I'm a backend engineer, if Young didn't say already, but I'm redoing the entire database for Eatery, and as part of that, I get to look through all the models. I get to create new classes and stuff, and we're going to be using GraphQL. It's going to be fun stuff, but I'll show you an example of what we're coding today for that. So imagine we have an Eatery entry, and it represents a single place you can go to eat on campus. So each eatery at one time, like maybe serving 0 or more times throughout the day, like you'll have breakfast, lunch, or dinner, all of them, neither of them, whatever it is, and each like subset of time they're serving food has its own food stations with corresponding meals and such. So from an object-oriented programming perspective, like we know how to model this. So how would you model this? With classes, with fields, getters and setters, and other handy methods that we want to use to mess around with our objects. So furthering our example, so each Eatery entry can be imagined as an object with its fields. So some examples that we'll use are like the name, like a description about the eatery, an image URL so we can put stuff up on the app, like the photos, payment methods, so if it accepts swipes, BRBs, cash, credit, Apple Pay, the location, so if you know if West Campus, maybe the actual geographic location, so you can give directions with the Maps app, and like operating hours, so like when is it open, can I go now, tomorrow, next day, whatever. So for all these, some of them have basic types like ints, strings, but the more complicated ones like payment methods and like location, we can make with their own specific object types respectively. And so this gives us kind of like a nested object structure that we can utilize and create more complex apps with this. So as said, each Eatery entry is like its own object in the programming language. It's referenced by a single variable pointing to the object, and it has its associated getter methods, what other things we want to create for functionality's sake. So this is a stripped down version of what we're currently using for the Eatery app actually. You see the basic information is like the ID, which is integer, names like Appel, ArcBCC, Beta House, an about, so just like a little description, an image URL. So these ones are easy to store and they're pretty simple, but what gets interesting is when we get to our own custom types. So for example, payment methods, we define our own type. I'll show that here. So a payment method can accept swipes, BRBs, cash credit, Cornell card, or mobile payments. We've decided to have all of these just be simple booleans, so we know immediately, can I do this, can I not do this? So then we also have like coordinates, which is again its own type, where we give it a latitude and a longitude. So that way we can allow the in-app, like whatever pod we use for giving directions, we can just give it a latitude and longitude and allow us to have our users find our places, which is kind of handy. Next things we like to do is like campus area. So Cornell Dining likes to say, I think we actually just on the Eater app, like, oh, this is on West Campus, this is on North Campus, this is in College Town, this is on Central, just like something that's more familiar to you guys as users. Like, oh, I know where that is, that general vicinity, so it's easier to direct you to that location. And then this is where we get into like the meat of like the core eatery data. From Cornell Dining's API, they call these things operating hours. It's actually like a lot more complex than simple hours, but we'll get into that. So operating hours has a date. So for example, today is the 22nd of October. You'd have a status, like status is open. An event is when we get into like the actual meal data. So an event type has its own like description. So say breakfast, this is breakfast. We have a start time, 10 a.m., end time, 1:30, calorie summary. Cornell Dining likes to provide a lot of health data on their apps, and something that we hope to like soon bring to the actual eatery experience. And now we can get into like the different menus. So for breakfast, we'll want a list of what are called food stations. So for an example, like at RPCC, you'll have the hot bar station, you'll have like a soup station, a grill, there's like the Mongo grill, there's the make your own pasta, like make your own salad bar, so those types of things. Within each food station, you'll want like a category, like, hey, this is the soup station. You'll have its own index, and the items reference a list of different food things. So for example, in the case of a soup station, you have like Alfredo soup, and then like a chicken noodle soup, I don't know, whatever's tasty like that. So as you can see, like that's the main, like that's basically all of eatery, which looks like not a lot, but at the same time it's not that complex. But if we were to write this all with setting up our own tables and having our own methods for each table, it'd get quite cumbersome really quickly, which is why we want to leverage ORMs by just having to define a class that has its own nested objects and custom things. We can just initialize an object and have that object store the data for whatever it's representing, and then just give that to a database to handle on its own. So it drastically simplifies the process for us as backend coders, and also, yeah, that's pretty much it. It makes our lives easier, which is wonderful. That's what we do it for. So before I continue, like, y'all get this, like, how it's, like, nested and you got this cool structure, yeah? Cool stuff? Yeah. I love this. I think this is fun. I have a fun time with it. So let's get into the pros and cons of using ORMs. So pros. First off, it's readable, especially if you define your variables nicely. It makes it really easy to say, like, oh, this variable corresponds with this type of attribute, and makes it really easy for us to think abstractly about implementing features and handling our code. It also kind of abstracts the complexities of SQL. So instead of having to think of like, oh, I want to select these attributes from this specific table where these conditions are met, you can just be like, yo, get me like all the eateries that are open today, and it'll just give you back what you want. And that's fantastic. I mean, it makes life a lot easier. The next thing that's nice is it integrates like the database logic with the application logic. So like I said earlier, with like getter and setter methods, when you can like have those reference like the specific objects. So maybe it's like when you're initializing something, you can have additional logic to keep track of whatever you want to keep track of. So like in the example of eatery, we can keep track of like when breaks are coming on. So when we update our database, we can be like, oh, if Cornell's on break right now, change all of the hours for each object to closed, because we can access that information and we want that logic there, so it's easy to update our database like that. And so those methods are nice for like integration and making things easier to implement nice features for the users. You also get, like I said earlier, cross-database compatibility. By using ORMs, everything is inherently tied to like the object and how you define your class, and whatever database you choose to use doesn't matter. You can switch from databases really easily, and you can choose like one day you're deploying on Amazon Web Services and be like, oh, I'm not liking this, and then you can use the same structure and how you define your classes and then just quickly be like, oh, let's deploy in Google Cloud now. Let's see if we like that better. So it gives like really nice like flexibility in that aspect. And then, of course, SQL injection is somewhat handled automatically because you're not directly uploading things like strings to a database for its like check in its tables. You eliminate the risk of like what we saw with Bobby tables, where they just input his name into their database and the database was just told drop the tables. With an ORM, you would put that string in an object, and then you could apply additional logic in there to ensure that an SQL injection will not occur. And you can limit that by like giving that level of abstraction before it actually gets to the database. And then, of course, we can code in whatever language you want to use. Python, I like a lot. We also do a lot of apps with Node. Java is also popular, but as you learn more languages and stuff, you can choose whatever fits your purpose and use whatever you like to use, which is really nice. So the cons. Because we create this nice level of abstraction, we actually make the query slower because the database has to do more computations to arrive at like what it wants to give you by looking through all your structures and such. So on that aspect, it's not as ideal, but in most cases, it's worth the trade. It also abstracts away the fundamentals of SQL. How we like to teach the course is get you familiar with SQL, and then we find it nice to throw on ORMs versus just giving you the best tools available, because then you lose the fundamental knowledge of being like, oh, this is actually how a database works with using SQL queries and the structure of the actual query. It's like very important to understand like the bigger picture with databases and be able to like know what you want to do and how to implement the features you want to implement in the future. One of the final cons of using an ORM is actually it increases the amount of, in some cases, increases the amount of code that you actually have to write, because you're defining all these classes and you have like whatever getter or setter methods and you have extra logic in there. It can sometimes make the code more cumbersome just to like fit the technicalities of defining a class and having your imports on check and such. So in that sense, it's not that big of a deal. Usually I find that ORMs make code cleaner, so it's easier to read. So in the end, it's easier to write and easier to read, so it can save you time still, even though it takes up more lines technically. Yeah.
So I posted a note on Piazza if you guys wanted to follow along. It's not required that you do. The completed code will be uploaded afterwards. So all right, so I'm in my VM and I'm just gonna go to the folder with the demo. And then basically do the typical setup stuff, so creating my virtual environment. Why is virtual environment not installed? Oh, wait, it's install. That's why. Do the Python thing.
Okay, cool.
Are you gonna release an updated requirements TXT for that? Or
Yeah.
they do it by themselves?
I'll do it. Or I can. Yeah, it doesn't matter.
Alright, so we're gonna go in our virtual environment and then, as always, install the requirements. So basically this demo will show us how we can use an ORM. So for Python, it's called SQLAlchemy. That's the one that we're gonna use, and it's pretty straightforward. You can basically create like Python classes of the objects that you want, and you're able to query them very easily. Okay, so basically, if you look in the DB file right now, it's pretty much empty. Except we have like a SQLAlchemy object that we created. So in our past demos, we've been doing like a to-do list. So the one thing that we want to model is like a task. So we can basically just say, make a class called task, and basically say like, oh, this is like a model. This is what we want our DB to, our table to look like. And then we can define our table name. And in this case, we just want to call it task. And then we can start basically saying like what fields are going to be in this. So in this case, like in a class, how you model that is like with instance variables. So I can say like ID, and then for SQLAlchemy, you can like specify, so like this is a column and it has type integer, and it's also a primary key. So this kind of avoids us having to do like that whole SQL syntax where we do like say like ID int primary key like not null, and then continue. You can do description, and this is a string, and we can just do this nullable, and that's false. So we can basically, and then our last field is done. So that's basically all our fields. This is kind of equivalent to our like create table whole query, where we can basically just say like, oh, these are the types of it, and these are like the parameters that they have, like primary key, or if it's like nullable or not. So like we can create a constructor for this class. So basically, Quargs like lets you put in as many arguments as you want with the key. So like it doesn't, I don't know how to describe it.
Oh, I can explain it.
Yeah.
Yeah. Wait, you want to just continue it? I'll write it.
Yeah.
Okay.
So like this is basically saying that like if a description was given in like was supplied as a parameter, then use that value, or our initial default value would just be like an empty string. So we make sure that like the field is not nullable, and then same for done. We say like if the user supplied a like a value for our done field, set it to that. Otherwise, make the default value false. Because like if you notice in like PA2 or PA3, if you ever sent like a post body with like a missing parameter, if you didn't check that, your code would like fail and be like, oh, like you're missing this field. So this basically handles that error. So like not all fields are required. Like we can just say like, oh, like we know like the default value for done is going to be false. So we can do stuff like that. And then basically if you, yes.
Is that, so those 2 stars before the argument name, is that just referring to like, what does that actually mean?
He's gonna show you what that means. And then also one last thing is we need like a serialized method, which basically, so whenever we like return our task objects, they're always in the form of a dictionary. So we need to figure out like how we can change this class object into a dictionary. So it's pretty simple. We can just do return, and then similar to how we implemented on our routes side, we can just do stuff like this.
Okay, so for the quarks thing, basically, this is a really nice syntax that allows us to have like shorter constructors or like functions. It's pretty versatile. There's also like a single asterisk version that's usually like star args, but you can look into that more. But kind of what it does is like, so our task has description and done, so we're trying to pass it to our constructor. So one way to do that might be like something like this. We have like task, and then we call that with two variables. So in that case, we would define our init method like self, comma, description, comma, done, right? Like how you would do it in Java or something. But if we add like 10 more fields or something, then it's kind of silly because you have like an init method, and then we would have self, comma, like field 1, comma, field 2, comma, field 3. And then it doesn't really seem like it has a point because we already defined the fields like in task, like why do we need to rewrite it? So this basically says like, oh, we can expect like a named dictionary. So instead of passing the arguments like this, we can pass in the arguments like this, where we specify like, oh, key A has value like task 1, we're like done has value false, and then we can get each of the arguments in the dictionary by doing quarks.get. So quarks is just a dictionary here. Does that make sense? It's like why we use that syntax. So it's basically a better, like a shorter way of defining really complex constructors.
Yeah, so so like how we talked about, like ORMs is really good for like defining relationships. So we're gonna add to this. So like in this case, like our to-do list has tasks, but let's say like we wanted each task to have like subtasks that you can do. So how we could define that is, well, first we can just basically copy and paste this class, since it's very like a subtask would have pretty much all the same fields as a regular task. So we can just rename this to subtask. The table name would also be subtask. But one thing, like similar to how we had like comments in post in PA3, like each comment belonged to a post, and how we represented that is like each comment had like a post ID. So in this case, for like subtask, it would have like a task ID to the task it belongs to. So how we represent like foreign keys with SQLAlchemy is we kind of do the same thing. We do say like it's an integer, and we can say it's a foreign key. And it refers to task.id, where task is the table name, and ID is the field that the foreign key is referring to. And we can make this nullable equal to false. And then we can just add this to our constructor. And then what we have to do on our task end is we know that every task has 0 or more subtasks. So we can define it basically almost like a list. Like a task has a list of subtasks, like a post has a list of comments. So we can just say how you define relationships is you just do like db.relationship and the class name. So we want this to be related to the subtask class. And so one annoying thing that you guys might have noticed is like when you delete, so like say we had like a post with lots of comments and we deleted the post, like what happens to those comments? Like sometimes they're still there. It's like very unclear like what's going on with that. And like we never want to keep like comments in the database of like a post that's deleted. So so like this ORM actually handles that automatically. So like we can say like this thing called cascade and we say delete. So basically what this says is like when we delete a task, delete everything, like delete all subtasks. Does anyone have any questions about that? Or does that make sense? Yeah.
What does cascade do or mean in this context?
Yeah, so in this context, it's saying like when a task is deleted, check all these subtasks, all subtasks that are related to this task and delete them also. So like you're not worried about like subtasks like that are in the database that don't belong to a task that like doesn't exist anymore. All right. So now how we can actually query them if we go to our app.py file. So this basically just points to our DB file. So kind of like last time. And then we can do some configurations. So like this line is basically just pointing us to where our DB is located, telling SQLAlchemy whenever you do queries or that kind of stuff, like look at this file. And this is just some stuff to, like when we run it later, you'll see that it has a lot of print statements. It'll basically like tell us like what's going on with the database. So those are just like different configs that these two aren't really important. It's mostly just this line that you should focus on. So this just creates our app, and then we also have to add this. So what this does is just saying like with our configurations, create all. So SQLAlchemy will handle initializing everything. So this create all method basically just creates all our tables for us and does that setup automatically. So how we would do, so like if we start with get task, how we can get all task is it's pretty simple. We can define a variable called task and just say task referring to the to our task class and just .query all. And this will basically give us a list of task objects. So how we can return these is, so if you remember our task, so this returns a array of task objects of the task class, but they're not necessarily in our JSON format or dictionary format that we want. So what we can do is, it's pretty nifty in Python. We can just say task.serialize for task in task. This is basically just like a very shortened version of a for loop that loops through all of our tasks and changes them into our dictionary format. Is anyone confused or have any questions about like what? Yes.
So the line above the task equals the capital T task.query.all. So you don't need to specify that capital T task is in that DB.
So
object.
if you look, if like we import.
Right, you imported it, right, like the.
Yeah. We imported our task class, and because this class basically extends like a model object from SQLAlchemy, it has all these like hidden methods that we're not really sure about. We also want to import subtask in that. So yeah, that's how you would query all task. So now how would we want to create a task? So it's it's just basically like creating an object. So in this case, I can delete this and just call the task class again, and then define like our description should be equal to post body.get. And why we want to use this get syntax versus like the bracket syntax is like, the get method, if it doesn't find a key with description in the post body, it will result to none. And if you like look back at our task app, we handle what happens if it's none. We make it by default becomes like this empty string. And then we can continue and say done is equal to bool post body dot get done. And then when we return our task, we want to make sure that we serialize it to our dictionary format. Does anyone have any questions about how we created this object or why we used get? All right, cool. Oh yeah. And then also one important thing is after you like define your task object, you need to make sure that you add it to your, basically how we make sure that it's written to our database is we say like, hey, add this to like our session that we're currently working on, and then commit that task to the database. All right. So how would we get a task? So basically what we can do is we can just say, referring to our task object again, we can do query, and then we can say we want to filter by ID is equal to task ID. And whenever you do these query methods, they return like a list of task objects that match this like filter. But we know that there's only going to be one task in this list, so we can just do dot first. And then if it doesn't return a none task, then we can just return the serialized version of the task. So how would we update a task? So first thing is we want to find if the task exists. So we would do basically the same query, and then say if task is not none, then we can so basically in this case we don't want to use like this index, like this bracket syntax, because like if they didn't supply a description, then it would automatically fail. So we can say task, we can assign our task description equal to post body dot get description. So that's saying if the user sends us a new description, set it to that, or else the default value should just be our old task description. So like if you notice with like the previous assignment, when you wanted to update a post, you would have to update all the fields. But like realistically, when you're updating something, you're not going to want to update all the fields. It might just be like one or two fields. And then we can do the same thing for done. We can say, do the same get syntax, and then default it to task.none, like the original value, if none was supplied. And then we want to save this to the DB, and then return the serialized version of the task. Does anyone have any questions so far? All right. So now if we wanted to delete a task, we would basically do the same thing. We would copy this line. Basically first find if that task exists. If it's not none, then we can just do basically call the session and say delete, and then just give it the task object that we want to delete. And then just say commit that to the DB. So it's much easier than having to do like that whole query with like delete from task where like ID is equal to this. So it's very simple. You can just do .delete and specify the object that you want to delete. All right. So now say we want to, like, how do we interact with like subtask and these relationships? So basically we can make a new route to get subtask. And then again, we can find the task that we're trying to get all subtasks for. And then we can say if task is not none, subtasks are equal to, so it's very simple to just access the subtask of a task. So we can just do that same like kind of for loop syntax where we do subtask.serialize for each subtask in our task object that we found .subtask. And then we can return basically that. And then if not, return the same error message. Does anyone have any questions on how we got the subtask? All right, so our last thing that we want to be able to do is basically create a subtask. So we want to have the same URL, but in this case, the method is going to be a post. So again, we find the task that we want to create a subtask for to make sure that it exists. If task is not none, then we want to extract our post body. And then now we can create our subtasks by referencing the subtask class that we defined in DB. Set the description equal to, we can have the same syntax. And then our post ID, or our task ID, is going to be just equal to the task that we found .id, or you can use this task ID that was in the URL. And basically how we add this to our database, how we tell that, oh, this subtask belongs to this task, is we can say task.subtask. So you can think about like task.subtask as basically an array of all the subtasks that a task has. So it's very simple. It's like logically or intuitively makes sense. So basically you just want to add that object to that list. So we just append that subtask, and then we want to commit this stuff to the DB. Does anyone have any questions about how we can map relationships in SQLAlchemy?
I have a more general question
Yeah.
about SQL. So it's a library that's interacting with like SQLite for you, basically.
Yeah,
So
exactly.
there is still a SQLite database behind it.
Yeah, so it, like you look at the very top, basically we point it to our SQLite database, and then it basically handles all of those queries that we were doing before. So yeah, we're still using SQLite, but we're using SQLAlchemy to interact with SQLite versus doing like actual SQL queries.
And then like you could switch the database. So like if you're using like some other like Postgres or some other database solution,
MySQL.
it would be really simple to switch. Yeah.
Yeah.
To switch that database like Postgre has to have this library, right? This SQLAlchemy or
Oh no, it actually doesn't. So like, do you wanna?
Yeah, so SQLAlchemy has support for all different types of databases. So like in this case, we like tell it that we want to use like SQLite. Like if you wanted to use like Postgres or MySQL, there's different configs that would do it. So like I think what you do is like you replace SQLite with like Postgres or whatever you're using. But it's very easy to switch over from database to database while keeping your code the same. It's just a matter of like the configuration that goes into it. If that answers your question. Okay. Yeah. Let's see. Let's hope it.
Oh yeah. So the reason why you also like it doesn't need to have support is because SQLAlchemy does the conversion of like your Python code into SQL. So like SQLite is still only interfacing with SQL, but the code, like the SQL code itself, is from SQLAlchemy. Yeah.
Yeah, so I just started the server, and then if we open up Postman, all right, so we just do like a get request to our task. Oh, I guess I actually have some stuff in the database already, but as you can see, here's like some tasks that we have. So it still works like normal. And then say like we wanted to get the subtask of this task, I might have something. We can just reference the ID and do our subtask. And you'll see, oh, like there's a subtask in here. And like say we wanted to make another subtask for this task, we can just put in, like say like this time, because before you had to post like, or never mind. But in this case, maybe like watch lectures. Let me send that. Oh, what's going on?
Yeah, what's up?
so how is that if it does the conversion
I'll
from
answer
you
the
to
question.
SQLite, how is that it's slower than doing it by yourself in SQLite?
How is this slower?
Yeah.
Well, like for example, for the query validation, like there are some additional steps that are run, but like if you knew that your database was secure in a specific kind of way, then like you wouldn't have to have those specific things checked, if that makes sense. So it just like checks everything. So if you had like really specific, like a very specific kind of database set up that you knew could like only be accessed in some way, or like some query is more efficient than others. Like for example, some advanced things that you can do with databases are like set up indexes on specific fields so that like accessing a specific field is faster than accessing other fields. Like then you would always write the SQL to, like you could write the SQL in a different way to be more optimal basically. Wait, what's that, Erg?
Not object, not
Can I see?
callable.
Can I see something?
Probably have a typo somewhere. Oh wait, go back, go up, over here.
Line 77, text object, not call. Post
Oh, I didn't do .get,
Yes.
that's why.
Okay.
All right, just a typo. So now we post. Okay, great. So yeah, so if we post, you can actually see that like a bunch of SQL queries were created. So like right here, it actually says like insert into subtask, description, like basically like what you guys had to write, and then has the values that we wanted to insert. So basically it comes up with all these SQL queries for you. You don't have to worry about handling any of this. So like After we create it, if we wanted to get all subtasks, we can see that it was added. Does anyone have any questions?
Oh, I have a question for you guys. So over here, we do like this session thing. This might seem pretty unintuitive. So here's like, we can create a task. Does anyone know why having some session object here is helpful? Like, why is this useful? Like, if we create a task, how come we can't just do, like, just commit it? Like, why do we have to have this add step? Or like, why can't these two things be combined into one?
Well, I mean, you might want to do a few things and then commit them all at once.
Okay.
So if you
Yeah.
can essentially like queue up tasks and then have them all commit
Yeah.
in a predictable way rather than committing each time they run.
Okay, so why do you think that's better? Like, is that actually
That's
better
a good
though?
question, but I think I feel like that like makes more sense
Mm-hmm.
because then you can like I think you have more precision over what the database is doing.
Yeah, so
you know
that's
exactly what-
a good point. Another like good, or I think the main reasoning behind it is if you think about it, like generally, so in our case, we're hosting SQLite on the same computer that we're running it on, but generally that's not the case. Your databases are somewhere very secure, like on some other server running somewhere else, basically, maybe even like across the country in some cases. And if you think about it, the most expensive thing about a database call is like actually making the call, right? Like if you're, let's say you're like iterating over tasks or something, which is a pretty common operation. So like let's say we had a like a for loop. Say we just want to like get some information on every single task, and then we do for task in like if we get all the tasks at the same time, get all or something. Let's just pretend that this is a method. This is just one call, right? So it's significantly less expensive than doing something like for maybe like task and IDs or something. Like if IDs is just a list, and then doing like tasks or maybe like db dot get task and then getting that specific ID. Or maybe this will just be ID, and then this would have been just ID. Like, this is just a significantly more costly way of doing it. You want to limit the number of calls that you make, and especially when you're working with an ORM, it's like easy to make the mistake of like making way too many calls basically, when you could just make one or two calls and then save a lot of time. So this is generally like the big bottleneck that you want to watch out for when you're working with ORMs, because like if you're making a call somewhere like halfway across the country, it could cost like 0.3 of a second, and if you make that call like 30 times or something, then it's just going to take a ridiculously long time, right? So that's sort of like the thinking behind having a session object, and having these decoupled was like very intentional, and that like just even preventing you from being able to add and commit at the same time sort of like forces you to think in this mentality, if that makes sense. Yeah. Any other questions, I guess? All right, nice. That's everything. Yeah.